What's up, friends? Welcome back to KimmyDTV. Welcome back to my dosage calculation series. In this video, we're going to be solving IV calculations problem. So this question reads, 1 liter of 0.9 sodium chloride is prescribed over 7 hours. The drop factor is 10. Calculate the flow rate, okay? So the first thing you guys want to know when solving a problem is like this is that there is a formula to it that you must memorize. So the formula that you will be using to solve this problem is, I'm going to use a red pen so that you guys know to memorize it. It's going to be volume times drop factor over time in minutes equals flow rate. Okay, and the flow rate unit is usually drops per minute, and then the drop factor unit is usually drops per milliliters. Now, the whole premise of solving a math problem with a formula is, in order to use the formula correctly, you have to be able to identify the different variables in the formula within the problem, okay? So for example, let's use a volume. So can you find the volume in this problem? So the volume is going to be 1 liter. But something you have to know about solving IV calculations is the volume is usually used in milliliters, okay? So you're going to have to convert the liters into milliliters. And if you guys didn't watch my last video on conversions, make sure you watch that. I'll leave it in the cards up above. So 1 liter, you're not going to input 1 liter in the formula, because guess what? 1 liter is equal to 1,000 milliliters. So you're going to input 1,000 milliliters in the problem, not 1 liter itself, okay? But the whole parts of the problem that you will be using to plug into your formula is volume. So volume is going to be the 1 liter part, but we know we're going to input 1,000 milliliters because we have to convert that. All right, 0.9 sodium chloride is not really important. It's prescribed over 7 hours, so we need time in minutes. So we're going to have to convert hours into minutes. So we're going to need that part of the problem. That's going to be our minutes. And it says drop factor. So this problem plainly tells you the drop factor is 10. So you don't really have to look for the drops per milliliters in this problem, because they plain out tell you, hey, this drop factor is 10. So you're going to need the 10. Okay, so it says calculate the flow rate. So this is the flow rate. So this part is what the question is asking for. Okay, so let's plug in what we've got here. Okay, so volume. We already said that the volume is going to be about 1,000 milliliters. So 1,000 milliliters. Okay. The drop factor times the drop factor, and the drop factor is 10 because it plainly says it, times 10. And then we're going to do it over time in minutes. So 7 hours is not minutes. So how do we convert hours to minutes? So just a quick formula. In order to convert hours to minutes, we are going to multiply by 60. So hours to minutes multiply by 60. So in this case, we have 7 hours right here. So we're going to use our calculator. Most nursing schools always allow us to use calculator because we have to be correct when it comes to saving people's lives. So I feel like that's why they allow us to use calculators. And on the NCLEX, they allow So 7 times 60 equals 420. So we're going to input that 420 over here for your minutes section. And through that computation, we're going to get the flow rate. So 1,000 times 10 equals 10,000, right? Yep. Then you divide that by 420. That will give you 23.8. .809. Okay, so we know that there's no such thing as 23.809523 of a drop. So when you're solving this problem, you have to remember that you must round it. So 8 is higher than 5, so that will make the 3 4. So rounding off, this will be 24 drops per minute. Yay! If you guys have any questions on this question, just let me know in the comments down below. Alright guys, so let's move on to question 2 of calculating using our formula for IV calculations. Alright, so the next problem reads 100 milliliters of 10% dextrose in water is infusing at 50 drops per minute. Okay, the drop factor is 10. How long will the infusion take to complete? So did you guys remember the formula I taught you? Maybe yes, maybe no, but my advice for when you're in nursing school and you're studying your formulas, or whether you're studying for NCLEX, whatever, is to, even if you know the formula and you can just blah 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 write the numbers, because you will, like, when you practice this over and over, like you just Google a bunch of IV calculations problems and then you keep doing them, you will like know it in such a way where you won't have to write the formula out, then find the numbers and plug in the variables. You will be that quick. But my advice is to always write out the formula, because sometimes the problem can look very different. Sometimes the problem is asking for different parts of the formula. So, and also when you write out the formula, it helps when you are memorizing. So because I like to do exactly what I do so I can help you guys, I'm going to write it over. Yes, it's repetitive, but guess what? With repetition, that is how you learn with anything in life, right? So let's write the formula all over again, and this will help you remember. So remember, the formula is volume times drop factor over time in minutes equals flow rate. Which is drops per minute. Okay, so can you guys identify the parts of this formula, the variables in the formula in this question? Okay, I can. So where can we find the volume? The volume will be the 1,000 milliliters of 10% dextrose in water. So 10% dextrose in water is not really the important part. That's just the medication that they're getting. That's just the fluid that they're getting. Okay, so it says it's infusing at 50 drops per minute. Okay, so if you are confused, like, oh, is it the drop factor? Is it the drop? Is the 50 drops per minute? Is it the drop factor, or is it the drops per minute? Well, look at the units. This says drops per minute, and this says drops per minute. So you already know that that will be the flow rate. See, so you already know that they're not going to be asking you for the flow rate because the flow rate is right here. See how we just did that there? That's why writing it out is good. Now we know the drop factor is 10, so they plain out tell you the drop factor is 10. That's awesome. And then the key question is how long, okay? The question is asking you, how long will the infusion take to complete? So they're asking you the time in minutes. They're asking you the time, how long, okay? So the way you would solve this problem is you would input the numbers. So I know my volume is 1,000. So 1,000 milliliters times the drop factor. The drop factor we already said is 10. Okay? Equals the flow rate. Remember that unit is drops per minute. Look at that, drops per minute. So we just put it here. 50 drops per minute is divided by time in minutes. So that's what we are looking for, right? So whenever we're solving this kind of problem, what we're going to do is 100 times 10, and we're going, sorry, not 100, 1,000 times 10. I made that mistake like several times, so don't make it. It's 1,000, not 100. So that's why I read the problem very carefully. You know, when you're up all night studying for your test and you also have dosage calculations exam, like you could say, oh, 100, but look at it carefully. There's 3 zeros, so this is 1,000. 1,000 times 10, and whatever's on the other side, you're just gonna divide it. So let me show you what I'm talking about. We use our handy dandy calculator because we can't make a mistake in patients' lives. So 1,000 times 10, that will equal about 10,000. Then we're going to divide it by whatever is on that side. Divide that, we're going to get 50. So that gives us 200 minutes. So usually when you're answering a question for your dosage calculations exam in nursing school or on the NCLEX, sometimes they would specify like, hey, can you put in hours? Because it's kind of weird to say, how long will it take to complete? Oh, 200 minutes. So that's not a problem. In order to convert minutes to hours, you're going to divide by 60. So let's put a little section right here to remind ourselves. Okay, to convert minutes to hours, we divide by 60. Okay, so 200 divided by 60 equals, now you don't see the decimal point, I don't think so in the camera, but this is actually a decimal point. It says 3.33333. So in the calculator you're gonna get 3.3333, like indefinitely. So this is how you do it. You see the first two numbers after the decimal point, this is what you're gonna multiply by 60 to get the time, and I'll show you what I mean. So you get this answer in your calculator, 3.3333, right? Whatever's before the 3, whatever's before the decimal point, I mean, is the amount of hours. So you already know it's going to be 3 hours. Whatever is after the decimal point represents the minutes. So in order to get the minutes, you have to multiply what's after the decimal point by 60. But you're not going to multiply all those 3. You're just going to take the first 2 numbers. And why I say for you to know this is because sometimes you guys may get, let's say for example, so I'm going to put this in a different section so you guys don't get confused. So for example, you may get 0.36825 in another problem. But if you know, let's say you got 2.36825 in another problem, but if you know that after the decimal point, you only use the first 2 numbers. Okay, so remember guys, in your dosage calculations class, you know, a lot of times they want you to get 100. I'm not gonna lie, a lot of times they want you to be perfect. So there's just certain things that you have to know, like the minute details are so important. You have to fine tooth comb everything. You have to be very meticulous about studying and like coming up with different methods on how to remember things, because that small little detail can, not to scare you, but that small little detail can indicate whether you pass your test. Okay, so I want you all to pass. So remember, the first two numbers after the decimal point, that is what you multiply by 60 to get the minutes. So it's 3 hours, because whatever is before the decimal point represents the hours. So that's an example, guys. So remember, this is just an example. This has nothing to do with the problem. I'm just giving you an example. So 3 hours, and then you multiply 0.33. So 0.33, and you multiply by 60 times 60, you get 19.8, right? So you get 19.8. So what's 19.8 minutes? So at this point, when you get 19.8, let's put that right here. So 0.33 times 60 gives you 19.8 in the calculator. So what's 19.8 minutes? You need to round that. Okay, so you can't say 3 hours and 19.8 minutes. That's not going to make any sense. Okay, so you have to get a whole number as the minutes. So how do we round? We know 8 is it lower than 5 or bigger than 5? 8 is bigger than 5. So 8 is going to make this 19 a 20. Okay, so the answer is, it's going to take 3 hours and 20 minutes. Any questions? Leave it down below.